Hi, welcome to chapter 2. So, as we jump into this chapter, make sure you have your paper and your folder and pencil, all this stuff, and we will go ahead and get started. Now, you will learn that this textbook is very different from a typical textbook. It takes everything that you've ever learned in this chapter or in this textbook and puts it into each assignment. So, every assignment requires a lot of upper level thinking, a lot of word problems, and I tried to make it as easy as possible by giving you all the multiple choice on Canvas. And it just takes it's a learning curve, that's for sure. And this chapter is very different from any other kind of math you've had because it's all about logic. And there's a lot of writing out sentences, which for you this year means a lot of typing out sentences. And let's just, I guess, jump in. So, our first vocab word, and that was not a highlight, our first vocab word is conditional statement. And this is something you can put on your theorem sheet. This is a statement in if then form. So, if I say, if you study, then this chapter will be easy, that's a conditional statement. It's an if then form. So, everything after the word if is considered the hypothesis. Now, your book also calls it the antecedent, and both words are interchangeable. Typically, if you Google this on the internet, and you're going to see that they call it the hypothesis. I don't know why your book called it the antecedent. And everything after the word then is called the conclusion. And again, your book calls it the consequent, and the words are going to be interchangeable for us. So let's go back to the sentence that I gave you. If you pay attention, then the lesson will be easy. Now, I just made this up, and I just wanted a sentence in if then form. So, if and then. Now, everything after if, again, is your hypothesis. If is not part of it. So just make sure, because there's some identification on your assignment, you just type out the part I highlighted here after the if until you get to the word then. And then the next part, so I have to use the word the as well, would be your conclusion. Okay, so now we will eventually go through if they're true or false. And like a sentence like this, you can't really determine that. But if it's a mathematical sentence, we will be able to determine the truth value. And we'll get to that in just a second. Okay, again, this is identification. Okay, so we're going to just circle for now because I know you're going to just type it out. What is the hypothesis and what is the conclusion? I'm not going to take the time to write it out. So the hypothesis is Lindsay studies for her test, and I'm going to label that hypothesis, or actually let's use the letter P. It doesn't really matter. And for your conclusion, she will pass, and that is your Q or conclusion. Next one, if Ben speeds on his motorcycle, so that's not the highlighter. If Ben speeds on his motorcycle, that is your hypothesis, or P, and he will get a traffic ticket is your Q. So notice here in red, I said don't use it or they in the hypothesis. So when you're writing these later, just remember we don't use it or they in the beginning. You can in the conclusion. It just grammar-wise, it makes you understand who you're talking about. And I will keep reminding you of this. We're going to rewrite each sentence or statement in the if-then form, which we know this has a name. This is called your conditional statement form. Let me write that out. Conditional statement form. Okay, that's the same thing. So we're not going to use it or they in the hypothesis, and that is your Q. So the first one, a triangle with two equal angles is isosceles. So here's a couple rules. Whatever information's at the beginning, try to keep it at the beginning. And if it's at the end, try to leave it at the end. So the word triangles at the beginning. So use that at the beginning, and isosceles is at the end, so we're going to use that at the end. So I can't say if it is something. You have to, like on this one, if the triangle has two equal angles, then it is isosceles. When you're finished, it needs to have the exact same meaning as the original statement. So let me see if I can get this done here. If the triangle has two equal angles, then it's isosceles. Now, a couple things. Notice it is in the conclusion, which is fine. And it has the same exact meaning. The word triangles at the beginning, like the original sentence. Isosceles is at the end, like the original sentence. This is the conditional statement. Now, is this true? If a triangle has two equal angles, then it is isosceles. This is 100% true, just as the original problem. All quadrilaterals have four sides, and a quadrilateral is like a rectangle, square, rhombus, trapezoid. They all have four sides. That's true. And you can't say if it is a quadrilateral, who is it? So we need to say it is the polygon, it is the shape, it is the object. We have to put some word in there to help describe it. So if the polygon is a quadrilateral, and I'm just going to abbreviate it for time, then I can say it because it's the conclusion, then it has four sides. And again, you can kind of change the wording around just a little. Just again, if you follow the rules. Did you put if then? Good. Did you put quadrilateral at the beginning of the sentence? Yes. Did you put four sides at the end? Yes. Does it have the same meaning as the original statement? Yes. So we followed all the rules. All cats chase mice. Okay. So pause it for a minute, see if you can do it. And as long as we have the same meaning, it doesn't have to be word per word the same. All right, hopefully you've already tried this. All cats chase mice. So if what? If the what is a cat. You can't just say if cat, then chase mice. I mean, that doesn't sound correct. If the animal is a cat, then it will chase mice. Now, again, yours doesn't have to be word per word the same. So, did you follow the rules? If and then? Yes. Did you use cat in the beginning? Yes. Did you use mice at the end? Yes. Does it have the same meaning as the original statement? Yes. All right. Let's move on. Okay, so here's a lot of information getting ready to come at you. So get your pencil ready. Now, we already know the conditional statement. This is what we've been dealing with so far. If angle A equals 15 degrees, then angle A is acute. Guys, our conditional statement is always going to be considered true. Okay, so even if you don't agree with it, we're going to say it's true. And that's always that way. Okay, now, converse, this is something new. What we're going to do is we're going to take the value of P and whatever the value of Q is, and we're going to interchange them. Now, the word if always stays in the beginning. The word then always stays here in the middle. But we're going to flip the two ideas. All right, so the symbols for this is Q, then P. We're going to switch the Q and P around. So we're going to write if, and I'm going to change the color here, angle A is acute, then the measure of angle A is 15 degrees. Now, this is not always true. We have to read it and determine the truth value. So truth value means, is it true or is it false? If angle A is acute, then it measures 15 degrees. Is that always true? Is every single acute angle equal 15 degrees? And of course not. This is false. And we would provide a reason. Why is this false? And this is called a counterexample. Now, a counterexample is not a lengthy explanation. It's you being devil's advocate, and you can provide one word that proves it wrong. So I could say 16 degrees. That would prove it wrong because an acute angle could be 16 degrees. You don't really need to write out a huge explanation that it could be any number. There are many, many numbers it could be. I mean, you could put 17 degrees, 80 degrees, 3 degrees. Okay? Give a short, precise, one-word explanation for your counterexample. Now, we have something called an inverse. An inverse is this little squiggly line. The squiggly line means negation. So let's practice what a negation is. A negation is like the opposite of. So the opposite of P, okay, let's see what a P is. A P, I'm making this up. The sentence is, it's cold outside. So the negation would be, it's not cold outside. So it's the opposite, the not of the statement. So if I would say, my favorite color is purple, you don't change the color. You would say, my favorite color is not purple. If another sentence would be, the student is on their phone, the negation would be, the student is not on their phone. Now, what if it starts out like a not statement? You could say, I don't like bananas. And then the negation would be, is I like bananas. So it's always just the opposite of the statement. So let's go back up here. The P, the hypothesis is angle A is 15 degrees. So we're going to say if the measure of angle A is not 15 degrees. Now we're going to take the negation also of the Q. Then the measure of angle A is not acute. You don't change it to obtuse. You just say not or isn't. And this is called the inverse. Now, there is a pattern. You notice at the very beginning, we have the P, then Q, and then we flip it, and then we negate it. So you guess it. We're going to flip it. So we're going to have not Q, then not P. So again, go back to the beginning. We're going to look at this Q value, which is angle A is acute. So we're going to flip it and put it in the beginning. If angle A is negated, not acute, then we're going to talk about the opposite of P. The measure of angle A is not 15 degrees. So that's the contrapositive. Okay, so again, make sure you write these down. You will need these. And we're going to keep practicing them. So let's write the symbols in. PQ, flip them, QP, negate them. Not P, not Q, and flip it again. Not Q, not P. Now, it asks for the truth value. The truth value means is it true or false? And if it is false, you're going to give me a counter example. And you know what? I didn't do that up here. Sorry. Let's do it real quick. For the inverse, if angle A is not 15, then it is not acute. All right, let's think about this again. If it's not 15 degrees, then it's not acute. So it's saying the angle can only be 15 degrees to be acute, which is false. It could be, again, 16 degrees. It could be a different measure besides 15 is what I'm saying. All right, let's look at the contrapositive. If angle A is not acute, then angle A is not 15. So if it's not acute, then it's not 15, which is true. Now, I'm going to give you the biggest hint there is, okay? So stay tuned here. For this class, there are only 2 different types of problems you'll have. You'll either have a question where everything is true, which this is not the case here, or it'll be what we have, which is true, false, false, true. So, which statements are always true? That's easy. Look at it. The statements that are always 100% true are the conditional and the contrapositive, if you wrote them correctly. Now, the converse and the inverse, they're always either both true or both false. So notice they're either true, true, or false, false. And that will really, really help you. Okay. So when you read the converse and you know it's false, then all of a sudden you know the inverse is false. Or if you read the converse and you know for sure that's true, then you know the next problem, the inverse, will also be true. So now let's jump into this one. I don't know if it changed my color. All right. Nope. There. Technical difficulties. My original statement here, if you notice, is not an if-then form. So we will need to change it for the conditional. It says all squares are quadrilaterals. And we already know we can't say if it is a square. So what is a square? A square, again, you can use the word polygon. You can use the word object. You choose. So let's write this out. If the polygon is a square, then it's a quadrilateral. And I'm going to abbreviate because I'm running out of room. That is my conditional statement. And I probably should have put that in the blank below. I wonder if I can move it. Yay, technology. Okay. So let's go ahead and highlight the P and the Q. So P and Q. Perfect. Is this true or false? How do you know? If it's a square, then it is a quadrilateral. It is true, plus we said the conditional is always true. So true. Now, technically, we already know another one's going to be true, don't we? Now, the two middle are either going to be true, true, or false, false, and we'll determine that in a second. If the polygon is a square, then it's a quadrilateral. Let's flip it. Can I say if it's a quadrilateral? Hopefully you're saying no. If the polygon is a quadrilateral, then it's a square. Okay, remember, quadrilateral is a four-sided shape. Rectangle, rhombus, square, trapezoid, parallelogram. So if it's that shape, if it's one of those, is it a square? No, because it could be a trapezoid. So my answer is false. And I'm going to say trapezoid. Now, I know we haven't talked about it, but don't say rectangle because technically a square is a rectangle. A little tidbit there. So let's now do the negation of P and the negation of Q. So we're going to say if the polygon is not a square. If the polygon is not a square, then it's not a quadrilateral. And I often underline the word not just for emphasis. You don't have to underline it. So is this true or false? If it's not a square, then it's not a quadrilateral. I always had the most difficulty with inverse because it's more confusing to me, but I remember the trick. If converse is false, then the inverse is false. Okay, and we can use the same exact explanation. It could be a trapezoid. The contrapositive, we're going to flip and negate this time. If the polygon is not a quadrilateral, if the polygon is not a quadrilateral, then it's not a square. Man, my handwriting's bad. I'm sorry, guys. I hope you can read it. All right, so That's a lot of information. If you need help, contact me, send me a message, attend a help session. All right, let's keep going. So your book really likes these diagrams. This is a Euler. His name's not Euler, it's Euler. That's how you pronounce it, diagram. And I often think of it just like in algebra class when you use parentheses. You always start with the innermost parenthesis and you work your way out. So notice your hypothesis is in the middle, and then the next one out would be your conclusion. So if whatever happens in the middle, then the next part. So when you see this for this first example here, do you know how to read it? And you will have to interpret some of these on testing quizzes. So you're going to say, if at first you don't succeed. Oh, my handwriting's getting worse as I go. Then try again. So that's how you interpret that. That is P, then Q. So again, remember the stuff on the assignment is higher order thinking. You need to apply the things that I have taught you and try to figure these out. Again, there's unlimited attempts on the homework, and come to help sessions or message me, and don't just struggle in silence. I can't help you if you don't reach out and say I need some help or assistance. And it's even harder this year because we're not in person. So don't be afraid to ask for help. That's what I'm saying. All right, guys, Jama try. See you later.